Hi students and the NPTEL learners. As of now, we already covered week 1 and week 2 assignment solutions answers. So if you have not seen, kindly go to my previous videos and then check out the week 1 and week 2 answers. The assignment deadline already over for week 1 and week 2. So now it's the time for solving the week 3 questions. The assignment deadline is 15th February. Okay, and also the week 4 video, also week 4 assignment also given. The deadline for week 4 is 22 February. Okay, so in today's class we are going to see the week 3 assignment solutions for the NPTEL oil hydraulics and pneumatics course. Those who are not subscribed the channel, kindly subscribe and get a real-time notification. So let me see the questions. So check out the first question. The following feature holds good for hydrostatic pumps. First of all, the case of hydrostatic pumps, we can take example for gear oil pump. So in the case of gear oil pump, two gears are arranged inside the casing. So one gear is driven and another one is a driving gear. So driving gear is mating with uh, motor, and due to the rotation of driving gear, the another one gear driven gear is rotating. Okay, so first option, creation of vacuum at the pump inlet, that is correct. So whatever it may be, in the case of pumps, initially we create a vacuum. So creation of vacuum at a pump inlet is correct, but the delivery of the fluid at the exit through external means, it is wrong. Okay, so by using that mechanical action of the gears, we force the fluid in the outlet pipe. Okay, so the delivery of the fluid at the exit through external means, it's wrong. So check out the question, option number 5, creation of the vacuum at the inlet and delivery of the fluid at the exit, the similar options, because of mechanical action of the moving element. This one is correct because we are using mechanical element as moving element as a gears. uh, we can take any other examples for positive displacement pump. Check out this chart. This is a positive displacement pump. So in the case of rotary pump, gear, screw and vane pumps are coming under positive displacement pump category. And then reciprocating type, another one type. In this category, axial piston pump and radial piston pump will come. Okay. So the option 5 is correct. And increasing volume and decreasing volume is most satisfactory operation of the pump. So whatever it may be, in the case of positive displacement pump, initially the vacuum is created uh, by the unmeshing of the gears. Unmeshing portion of the gear, the volume is get expanded and increased, and then the volume is get decreased in the meshing of the gear part. So increasing volume and decreasing volume is most satisfactory operation of the pump. So due to that operation only, we will get a positive means positive displacement pump means we get a whatever quantity the coming to inlet, the same quantity will come to outlet. That is a positive displacement pump. In the case of non-positive displacement means, the whatever quantity the water or oil is sucked by the pump, it deliver the less quantity compared to the initial quantity. Okay, so that is called as a non-positive pump. So the option 2 is correct. And then the case of large tolerance between the movement elements. In this case, uh, always the gears are in a tight manner, and there is a tight tolerance between the moving elements only applicable in the case of positive pumps. So option 3 is wrong and option 4 is correct. So as per the first question, the options number 2 and 4 and 5 is correct. So check out the next question. The following are the positive displacement pump. First one, centrifugal pump, and second one is a gerotor pump, and third one is an unbalanced pump, and fourth one is a axial flow pump and rotating swash plate pump. Okay, now check out the chart again. In the case of gerotor pump, is coming under positive displacement pump. Okay, and then unbalanced vane pump. So the case of centrifugal pump is a non-positive category. Okay, so the question they are asking positive displacement pump. So centrifugal pump is wrong. The similar case axial flow pump. Check out that centrifugal and axial flow are non-positive displacement pump. So that also wrong. And then vane pump and swash plate pump. Check out here. Swash plate pump is coming under positive category and vane pump is coming under positive category. Vane pump is two different types. One is balanced and unbalanced pump. Check out here. So based on this condition, the options 2, 3 and 5 is correct. The question number 2. Question number 3. Which of the following is odd man out? So odd man out means which is different compared to the comparison of all 5 options. In the case of gear pump, vane pump, screw pump, low pump. Check out here. Gear pump, screw pump, vane pump. Gear, screw and vane all are positive displacement. And then the case of low pump is one of the okay. In the case of low pump is one of the model of external gear pump. For example, check out this particular diagram. External gear pump. In this external gear pump, the gears are arranged inside. Okay, but to remove that gears and then the lobes are attached. The similar casing, everything will be same setup only. In this external gear setup, the gears are removed and then lobes are attached. So this is also one of the positive displacement pump. So gear pump, balanced vane pump, screw pump and low pump. So everything is coming under positive displacement pump, which is in a category of rotary type. So all the categories are coming under rotary type. But in the case of reciprocating type, the piston pump will come. Okay. But anyhow, piston type is a positive displacement pump only. But in the case of odd man out, which one is a different? So all the other pumps other than piston pump, all the other pumps are rotary type. So this particular piston pump only reciprocating type. So this particular piston pump is the different one. So I chose the piston pump is the answer. So question number 4. Features of ideal pump are, so in the case of ideal pump, we don't have a loss. So having no losses, that is the answer for ideal pump. And then option number 3, theoretical flow rate independent of uh, differential pressure across the pump. And actual torque, in the case of ideal pumps, the actual torque is greater compared to theoretical torque. But ideal pumps are not a real pump. normally idle pumps are not existing. Okay, so for know the features of the ideal pumps are we don't have no loss. Okay, so option 2. And then in the case of ideal pump, the radial flow rate is not depend the differential pressure. So the option 3 is correct. And then the actual torque, which is greater than the theoretical torque. Always the theoretical torque is lesser. Okay, so the actual torque is always greater. So the option 5 is correct in the case of ideal pump. So question number 5. Which of the following holds good for the vane pump? In the case of vane pump, first option always hydraulically balanced pump. So we have two different types. One is balanced pump and unbalanced vane pump. So first option is not correct. Okay. So second option may be balanced or unbalanced. So two types are covered in this particular option. So option 2 is correct. And slotted rotor and reciprocating vanes. So the once you check the construction of the vane pump, there is a slotted rotor is available, and then the due to the reciprocating action, the uh, oil is sucked in the inlet and then it is delivered at the outlet. So direction of eccentricity, there is eccentricity available in the case of vane pump. So due to the eccentricity, it alters the inlet and outlet. In the case of uh, vane pump, volumetric displacement does not depend on eccentricity. It is depend on the eccentricity. Whatever the volumetric displacement.
Hello students and NPTEL online video learners. So today we are going to see the week 3 assignment question solutions. So already I covered week 1 and week 2 assignment questions in my previous videos. Those who are not a visitor, you can check it out. And already the week 1 and week 2 assignment submission date was over. Now the week 3 assignment date is 15th February. So before that, you can check out the solutions for the assignment for week 3, and week 4 also started. In the week 4 assignment deadline was given as 22 February. So soon I will upload week 4 assignment solution also in the upcoming week. Okay. So before that, you get a real-time notification. You can subscribe my channel. Okay, if you really like it, you can give a like, and if you have any comments, you can give a comment in my chat box. Okay, thank you. So now we will see the week 3 quiz assignment questions. So check out the first question. The following feature holds good for hydrostatic pumps. So first of all, we have to know about the hydrostatic pumps. So in the case of hydrostatic pumps, initially the uh, water or oil which is sucked by a pump by the means of vacuum. Once vacuum created, automatically the suction side, the water or oil is gets sucked by a pump. After that, that oil is delivered by means of mechanical action. For example, uh, I just show the external gear pump. Have a look on this particular picture. External gear pump. In that particular gear pump, here the inlet side the water is coming due to the rotation of these gears, due to the mechanical action, and then this water or oil is going inside. Mostly the external gear pumps are used for delivering the oil from one place to another place. Okay, so we just imagine oil is coming here and then oil is coming out. So due to the vacuum creation, by the rotation of the gear elements. Okay, so vacuum is created in the inlet. So now come to the question. Creation of vacuum at the pump inlet and delivery of the fluid. This point is almost correct, but at the exit through external means, that was a wrong comment. Okay, at the exit through external is not possible in the case of hydrostatic pumps. You just check out the last option. Option number 5, creation of the vacuum at the inlet and delivery of the fluid at the exit. So same content is given because of mechanical action of the moving element. So because of mechanical action of moving elements means moving element, they are stated as it is a external gear pump. Okay, so due to that moving element, the oil is delivered in the delivery side. Okay, clear. So option 5 is correct. Now check out the option number 2, increasing volume and decreasing volume is must satisfactory operation of the pump. Let me go to the picture again. In this particular place, inlet side, the gears are unmeshed, so the volume is increased, and then again the gears are meshed, so the volume is get decreased. So the oil is going inside and then coming out. Clear. So increasing volume and decreasing volume is possible in the case of hydrostatic pumps. So that only given. So option 2 is correct. Now the third option, large tolerance between the moving elements. Check out the picture. The gears are in a tight manner inside the casing. Okay, so there is now no possibility of large tolerance between the moving elements. So only tight tolerance is possible. So option 3 is correct. So in first question, option 2 and 4 and 5 is correct. Option 3 is not possible, and option 1 is not also possible. So now question number 2. The following are the positive displacement pump. Before see the options, we have to see the tree diagram. So tree structure of pumps. So the question is they are asking positive displacement pump. Okay. So check out the options for non-positive displacement pump, centrifugal and axial flow. Okay. So other than that, all the pumps are coming under positive displacement pumps. So in the option centrifugal and axial pump, we can ignore that, and other than that, all the options are coming under positive displacement. Okay. So now let's see the option question number 3. Which of the following is odd man out? So options are gear pump, vane pump, screw pump, piston pump, low pump. So now again we go to the tree diagram. Actually, in the case of pumps, there are two different types. One is positive and non-positive. So positive displacement pump means the whatever the quantity of oil sucked by the inlet side, the same quantity will be coming out in the outlet side. That is a positive displacement pump. So in this, on the other hand, whatever the fluid you sucked in the inlet side, the similar quantity will not come in the outlet side. That is a non-positive displacement pump. You can take an example of centrifugal pump. Okay. So now check out the question once again. Which of the following is odd man out? So odd man out means which one is a different pump? That is a question they asked. Okay. So gear pump, vane pump, screw pump, low pump. Check out that. So in this particular side, positive displacement pump, there are two types. One is rotary type and another one is a reciprocating type. In the rotary type, gear, screw, vane, balanced vane or unbalanced vane. So we can take vane pump as all coming under this that category. So three pumps, and then low pump. Actually, low pump means once again gear pump, vane pump, screw pump. There these three are coming under rotary category. So low pump also rotary category only. Just see the picture. This is a picture for lobe pump. Okay, so in this external gear pump, the gears are removed and then the lobes are fitted. Okay, there is no different separate option for lobe pump. Initially, the depend upon the applications, the gears are removed and then lobes are installed. So other than the casing and everything will be the same dimension will be followed. So only depend upon the applications, the gears are removed from the casing and then the lobes are installed. Okay, so that category is lobe pump. That also coming under rotary category only. Okay, so in the case of odd man out category, which one is a different? Odd man means which one is a different? Piston pump is only different. Piston pump is coming under reciprocating category, but both are positive displacement pump only. But rotary type, gear, screw, vane, and lobe pump. Reciprocating type, piston pump. So piston pump only different one. Okay. So option 4 is correct. So next question: the features of the ideal pump. Once again. So in the case of ideal pump, it don't have any loss. Ideal pump is it is an imaginary pump. So we just imagine the pump don't have any loss. Okay, and then the case of the theoretical flow rate, which is independent of differential pressure. Okay, and then actual torque, which is greater than theoretical torque. We just assume like that. So the actually ideal means it is a imaginary one. It is not existing, but we just imagine these kind of properties we have. For example, in the case of ideal fluid, it is not a it is an imaginary fluid. It is not existing. Similarly, ideal pump means it is not existing. We just imagine. Okay, this kind of properties it have. Based on that, we created a real pump. So these are the options. It don't have any losses, so having no losses, and option number 3 and option number 5 is correct. The question number 4. So now check the question number 5. Which of the following holds good for vane pump? So actually in the case of vane pump, once again I go to picture. This is a picture of vane pump. Okay, so in the case of vane pump, it have a two different categories. One is a balanced one and unbalanced one. Check out here. In the case of vane pump, it have balanced and unbalanced vane pump. In the case of fixed displacement, so maybe balanced or unbalanced, that option is correct. And slotted rotor and reciprocating vanes, that option also correct. It contains slotted rotor and reciprocating vanes. And direction of eccentricity alters the inlet and outlet. It contains an eccentricity. Eccentricity means there is a shaft in this particular vane pump, and then over that there is a cam arrangement is there. So the cam center and the shaft center, it is in a same axis, then the eccentricity is 0. Once during the rotation, the eccentricity will be changed. The shaft axis and the cam axis, the eccentricity will be greater. uh, so that only mentioned here. Direction of eccentricity which alters the inlet and outlet. And volumetric displacement is depend on eccentricity. It does not depend. Option is given, so it is not possible. Volumetric displacement is depend on eccentricity. Okay. Based on the eccentricity, for maximum eccentricity, the maximum volumetric displacement will be created. Minimum eccentricity, minimum volumetric displacement will be created. So it is dependent only. So the option 5 is wrong. Now check out the question number 6. this particular problem, you can check out the similar problem in the video lecture of NPTEL course week 3. So now I will show the actual calculation behind this particular problem. Here the here they mention a gear pump which contains 12.5 centimeter cube. So centimeter cube means it indicates volume. Geometric volume, which is operated at 1800 revolution per minute, which is a speed, delivers the oil at 16 megapascal pressure, and we have to assume it is an ideal pump. Calculate the hydraulic power and driving torque if the inlet pressure is 200 kilopascal. Okay, now I will show the calculations. Check out the question calculation. So volume is given 12.5. We convert the value into meter cube. So 1 centimeter is equal to 10 power minus 2 meter. So we convert the value centimeter cube into meter. So 10 power minus 6, 10 power minus 2 power cube. So 10 power minus 6. So n is equal to 1800 rpm. So revolution per minute. So convert the value to revolution per second. So 1 minute is equal to 60 seconds. So I just apply 1800 by 60, which is equal to 30 revolution per second. And then outlet pressure minus inlet pressure, that is a change in pressure delta P. Outlet pressure mentioned as 16 megapascal. Mega means 10 power 6. So apply 10 power 6. Pascal, we change it. 1 Pascal is equal to 1 Newton per meter square. So 16 by 10 power 6 Newton per meter square. So and then inlet pressure 210 power 3 Newton per meter square. So kilo means 10 power 3. So I apply the values and then we got answer. Delta P is equal to 15.846. So we have to find out first hydraulic power and then torque. So in the case of hydraulic power, the formula is torque into speed. So initially we have to find out the torque value. So formula for torque is equal to volume into delta P by 2 pi. We apply the values and then we got answer. T is equal to 31.43. And once we got the answer for torque, we apply the value here. So torque value 31.43 into 30. So we got an answer in terms of Newton meter per second, which is equal to watt. So power is equal to 943 watt. Now check out the options. In the option 31.4 is available. Two options. 31.4 indicates driving torque, and then in third option the power value is given as a 600 watt, but we got an answer 943. So which is relevant to option number 5. So the answer is option number 5, 1000 watt and 31.4 Newton meter. So now check out the question number 7. This is also another one question relevant to gear oil pump. So module of the gear, width of the gear is given and number of it is given. So pressure angle given and pump speed is given and volumetric efficiency is given. Now I will show the calculations. So we have taken modules equal to m, 8 mm is equal to 0.008 meter, and width of gear is equal to 30 mm is equal to 0.03 meter. So already we know 1 mm is equal to 10 power minus 3 meter. So I just apply that. Number of bits is equal to 16. Pressure angle is equal to 18 degree. Volumetric efficiency is equal to 0.94. Pump speed is equal to 1800 rpm. Now the question is find the actual delivery of the pump. So the formula for volumetric efficiency is equal to QA by QT. QA indicates actual delivery. QT indicates theoretical delivery. Sorry, it is not a theoretical efficiency. It is a theoretical delivery. So QT is equal. We can find out the QT. Once we find the QT, we have apply the value here and then find the QE. Our ultimate aim is find out the QE. So QA is equal to QT into efficiency that is volumetric efficiency eta V. First we got to find out Qt is equal to V suffix d into n. So Vd indicates the volumetric displacement. So displacement volume formula we have to know for, especially for gear pump, by using the module and number of the pressure angle, so width of the gear, everything we have to apply in this particular formula, and then we can get an answer of Vd value 2.142 in 10 power minus 4. Okay. After that we apply the value in the Qt formula and calculate the Qt value, and I got an answer Qt is equal to 0.386 meter cube per minute. But in our question they asked me actual delivery QA. So calculate the QA 0.386 into efficiency by using this particular formula. Okay. So final answer is 0.363 meter cube per minute. Now check out the answers. So the answer actually I got this 3.363, the nearest answer. So almost accurate answer is available 0.3603. Okay. So the option is, so sorry, the answer is option number 2. Now check out the question number 8. Volumetric displacement of bent axis axial piston pump does not depend on, once again I just show the formula. Actually they are asking volumetric displacement of bent axis axial piston pump. Okay, so once we know the formula for volumetric displacement for bent axis axial piston pump, we can easily write the answer. See here, this is the answer, sorry, this is the formula for volumetric displacement for bent axis pump, which is independent to number of pistons, area of piston, diameter of piston, and offset angle theta. Okay, now let's check the options. So bent axis axial piston pump, it is does not depend on, it is not which one is not depend. Now check number of pistons mentioned here, area of pistons mentioned here, piston diameter mentioned here, offset angle mentioned here. Okay, so only thing is piston stroke, that only not mentioned, and it is not depend. So other than all the options are depend on the volumetric displacement. So from the formula we can easily take out the answer. So the answer is option number 4, piston stroke. So which of these points are considered to avoid pump cavitation? So now I will show the concept. Okay. These are the points we have to consider to eliminate the control of cavitation. So always we have to keep the suction line velocity below 1.2 meter per second. Now check the option. Keep the suction line velocity below 1.2 meter per second. So the option number 5 is correct. So above is wrong. So the question they asked is which one we have to consider for avoid pump cavitation. So option number 5 is correct. So next thing, keep the pump inlet lines as short as possible. Check out the option number 4. Keep the pump inlet line as large as possible, they mention. But actually we have to keep as short as possible. So that option is wrong. And minimize the number of fittings in the inlet line. Check out here. Minimize the number of fittings in the outlet line they given. If they given inlet line means it is correct one, but they given outlet line. So it was wrong. And mount the pump as close as possible to the reservoir. So option number 1, mount the pump as close as possible to the reservoir. Same content is given, so this one is the correct one. Okay. So
Based on these options, the option number 1 and 5 is correct. Other than the options are wrong.
Okay, now let me see the question number 10. In this particular question, they are asking the theoretical flow rate, which is in liters per minute, from a fixed displacement axial piston pump. They asked, okay, and the given data are 9 cylinders and speed is 5000 rpm. The diameter of piston is 20 mm and stroke length is 50 mm. Now let me see the answer. Check out the answer. The number of pistons we can take an small n is equal to 9, speed capital N is equal to 5000 rpm, piston diameter which is equal to 20 mm. We convert the value to meter. Stroke length is equal to 50 mm. Convert the value to meter. And we have to find out theoretical flow rate QT is equal to formula VD into N. VD means volumetric displacement or displacement volume, which is equal to volume, actual volume into number of piston. So actual volume is equal to area into stroke. Volume formula we already know. Sorry, volume unit we already know. It is in terms of meter cube. So area unit is meter square into stroke. Stroke form unit is meter. So meter square into meter, meter cube. So we have to find out the area. Area pi by 4 d square formula we apply, and we can easily calculate the area and apply the area into stroke values in the volume formula. We can find out the volume value. Once we calculate the volume value, we apply the value in this particular formula. Qt is equal to Vd. Vd volume value we can apply 1.571 10 power minus 5, and number of piston 9 we applied, and then uh, convert the speed value 5000 by 60 revolution per second. So we got an answer 0.01178 meter cube per second. Okay. So but in this particular question they asked the answer in terms of liter per minute. In terms of liter per minute, we can convert the meter cube per second. So we already know 1000 liters equal to 1 meter cube. Okay, so in 1 meter cube we apply 1000, that is 10 power 3 I applied, and 1 minute is equal to 60 seconds. So 1 second is equal to 1 by 60. So instead of seconds I apply 1 by 60. So 60 will go upward, and then 0.01178 into 10 power 3 into 60. So we got answer 706.5 liter per minute. So check out the options. So same option is available 706.5. So the question number 10 answer is 706.5 liter per minute, liters per minute. So these are the answers I got, and I hope these answers are almost correct. Okay, students, hope you like this particular week 3 solutions video. So if you find any difficulties or if you find any answer is incorrect, kindly mention your comments in the uh, YouTube checkbox and type the messages. Then only I can able to change the options. So our ultimate aim is to get a full mark in the assignment assignment number 3. So suppose if I miss any, if I did anything wrong means you just mention that in the comment box. Kindly mention it. So before 15th we can easily rectify the problems. Okay. So our ultimate aim is to do the things before the deadline. So we already know the deadline is 15th February. So before that you just tell if anything wrong we find. Okay. Thank you, students.